Guys, today I'm going to be doing 2024 mock question 9, but I'm only going to be doing the calculation of the KC expression and the value. So this is a really good video if you want to learn how to do the KC type of calculations, I suppose. So first things first, you're going to want to transcribe let me just show you the question. I'm just going to be doing part C. So it says write down the equilibrium constant Kc expression. So for that, we're not going to need any of the values like the mass or anything. We're just going to need the equation. So the Kc value is always the products on the top and the reactants on the bottom. So in this case, the left-hand side is the reactants and the right-hand side is the products. So it always goes like that, because if you think about it logically, obviously it's going to go from the reactants are going to go in and the products is going to come out. So let's write it down. And don't forget your square brackets, okay? They're really important. So but one thing not to forget about is these big numbers, the coefficients. You're gonna take them into consideration by by putting that number to the power of SO2. So in this case it would be 2. For oxygen it's just 1, so you don't even need to put that in there, because anything to the power of 1 is always itself. And then this would be 2. Okay, so for doing this you will get a total of 6 marks. And then the next part of the question is about solving the actual Kc value. Okay, so for that, I'm just going to rewrite okay, and let me put in this little box what the question gives me, like what information I get from the question. So it says 80 grams of sulfur dioxide and 24 grams of oxygen they're mixed in 5 liters. 20 liters. Okay, and then that produces 88 grams of SO3. And then from there, we have to figure out the Kc value. So basically what we're trying to get is values for these, so we can sub them in and find one number, okay? So I like to use an acronym for this called ICE, okay? ICE. I is for initial, C is for challenge, C is for change, and E is for equilibrium. So the initial value is always in moles, but unfortunately we have our values in grams. But that's no problem if you remember the formula for calculating the moles, which is equal to mass over relative molecular mass. So this is just these values that are given to us in the question, and the relative molecular mass is one that you have to get from the periodic table, the bigger number, not the atomic number. Okay, so we know that the relative molecular mass of sulfur is 32 and of oxygen is 16. So SO2, there's one S and 2 O's, so that would be 16 plus 16 plus 32, which would be 64. So that is the relative molecular mass, so it's going to go in the bottom, 64, and the mass of the SO2 is given as 80. So you're going to put that into your calculator. 80 divided by 64, and you get 5 over 4, or 1.25. I'm just going to write it as a decimal. So the initial value of SO2 is 1.25. Then we're going to do the same thing with oxygen. So the relative molecular mass of oxygen is 16. Multiply that by 2 because there's 2, yeah? That would be 32, that goes on the bottom. And the mass at the top, which would be 24, as given in the question. So 24 divided by 32, and it's 0.75. Let's write that down. And the initial value for the products is always 0, because initial just means start, and like obviously in the start there will be no products as the reactants haven't reacted together, I suppose. So now this part, change, means basically ratio. This is when the ratio comes into play. So we can see that it's 2 is to 1 is to 2. The ratio is determined by the numbers in front, by the way. So when the reactants react, it gives a bit of it off to form the products. So, but we don't know what that is. So we're just going to say X, and it gives it off, so it'd be minus. But there's 2, so I'm going to say 2x, and it's 1 on this case, so it'd be minus 1x. But for the reactants, it doesn't take it away, it gains it, so that would be plus 2x. Okay, and don't get confused just when you see x. That's just basically like putting a question mark, like we're just saying we don't know what that is yet. Okay, but now moving on, it says we formed 88 grams of SO3. So that would be at the end, like when equilibrium was reached, they formed that, and they said that in the question. So we're going to turn SO3 into moles. That would be 3 oxygens, which would be 16 times 3, plus the 32, which is 80. So that's the relative molecular mass over, and then the mass on top. So 88 over 80, which gives you 1.1. Okay, and now at this point you might be like, oh, what do we do next? But you just have to think, what are we looking for? We're looking for the values of them at equilibrium, because that's the only thing that's missing from our little chart, yeah? So basically we have to take away this from this, this from this, and get our answers. However, we don't have the x values, but we figured that out by looking at these two. So it says 2x was formed, and that 2x is 1.1. So if 2x is 1.1, 1x would just be divide that by 2. So 1.1 divided by 2, which would be 0.55. So here we have it. X is 0.55. Okay, so we're gonna sub that in. So we're gonna now take away 1.25 from minus 2 multiplied by 0.55. 1.25 minus 2 times 0.55. We get the answer of 0.15. Okay. And then you're going to do the same thing for oxygen. So 0.75 take away 0.55, which gives you 0.22. However, you might make the mistake and sub them into that, but no, because it says 20 liters. Like, they don't just give you information for no reason. So we've used this, we've used this, we've used this, but we're left with this, yeah? Because they put it in 20 liters, and moles is per liter. So we need to divide that by 20 to get it in 1 liter. So 0.15 divided by 20 gives you 0.0075. And 0.2 divided by 20 gives you 0.01. And 1.1 divided by 20 gives you 0.055. Okay, so here's our 3 values that we've been looking for to sub into this. So this, as you trace back, it's SO2, O2, SO3. So let's just sub that in, okay? So Kc is equal to, and we're subbing it back into this, okay, guys? So SO3 is 0.055 to the power of 2. Sorry, don't forget your square brackets. then 0.0075, and then 0.01. Okay, put all that into your calculator. Get your answer of 5377.7, and that is your final answer, and you will get for that 12 marks. Okay, and 12 plus 6, 18, so you get a total of 18 marks for doing that. Okay, that's all for today.